Students, sound waves are longitudinal waves. The particles of the medium vibrate to and fro in the direction of the motion of the wave. As a result, they come close and go apart. Thus they form compression and rarefaction. The place where the particles come close is called compression, and the particles that go apart is called rarefaction. The distance from one compression to the consecutive compression is called wavelength. Students, the compression and rarefaction can be seen on a helical coil. The number of waves produced in 1 unit time is called frequency. The frequency is measured in hertz. You have studied about these terms in the preceding sections.
Wave. Students, you all know about energy. You also know about the different forms of energy. For instance, let us consider two forms of energy, light energy and sound energy. These forms of energy travel from one place to another. Now tell me, does light and sound travel in the same way? No, they travel in different ways. We can see the light of sun, moon and stars, but cannot hear any sound from these heavenly bodies. Do you know why? Students, the sound energy requires a medium like air, water, etc. to travel. But the light energy does not need any medium to travel. It can travel through nothingness or vacuum. Some forms of energy, like sound, travel only through a material medium, while the other forms, like light, travel in a material medium as well as in vacuum. Students, what happens when you drop a stone in the stagnant water of a pond? It produces a disturbance in the water. The disturbance produced in the form of small circles gradually expand and move through the surface of water. Here, the kinetic energy of the stone produces disturbances in the water of the pond. When energy passes through a medium, it produces disturbances in the medium, which we will call a wave. Here, a wave is produced in the water to pass the kinetic energy of the stone through water. The wave causes the particles of the medium vibrate. As the wave travels through the medium, it transfers energy. Thus, a wave is the disturbance produced in a medium by the passage of energy. It is in fact the path through which the energy travels. Students, you must have noticed the lightning or thunder that occurs sometimes during rainfall. You see the light as a spark first and hear a sound after a while. Can you say why this happens? Students, lightning occurs due to some collision in the clouds where both sound and light are produced at the same time. The light travels much faster than the sound, so light from the cloud reaches us earlier than the sound, and we see the light first. Now you can simply understand that different forms of energy travel with speed. Different forms of energy have different capacities to travel. Do you know why? Yes, every form of energy travels through a wave, but the wave produced by different forms of energies may be different. Some waves are produced only in a material medium, while some other waves are produced in a medium as well as in vacuum. Some waves have less speed of propagation, while some of the waves have high speed. Thus, there are two types of waves. There are mechanical waves and non-mechanical waves. The mechanical waves are produced only in a material medium. It can propagate through solid, liquid, or gas, but not in vacuum. On the other hand, non-mechanical waves are produced even in vacuum. It can propagate through the vacuum and through a material medium also. We often call non-mechanical wave as electromagnetic waves. Students, can you say now which type of wave is a sound wave and which type of wave is the light wave? As you know, sound cannot travel through a vacuum. So a sound wave is a mechanical wave. Light wave is an electromagnetic wave as it travels even through the vacuum. Students, different waves have different directions of movement of particles of the medium. This makes a difference in the structure of the waves. When a sound travels through the air particles move forward and backwards. Unlike to this, the water particles move up and down when a wave is formed by the stone dropped in it. The wave in which the particles vibrate at right angle perpendicular to the direction of flow, propagation of energy, is a transverse wave. The wave produced in water by the stone dropped is a transverse wave. And the other one, in which the particles vibrate along the direction of flow, the propagation of energy, is a longitudinal wave. The wave produced by sound in air is a longitudinal wave.